question 3a, and here we're starting on looking at the exponent rules that we use when simplifying algebraic terms. So in this problem we see that there's a set of brackets, and everything inside of that 3x squared, is being taken to the power of 4. So if we use our power rules with brackets, we'll find that we need to take that power and put it onto the numbers. So put power on the numbers, or the coefficient in front, power on number in front, and then we times the powers inside bracket to power outside bracket. So what happens there is if we take 3 here, we're going to take it to the power of 4, so that's going to become 3 to the power of 4 x squared, but it was a 2 and we're going to do 2 times 4, so in this case that becomes 8. So again, we've taken the power of 4 on the outside and we've put it on the number to take 3 to the power of 4. It's not the same as 3 times 4, but 3 to the power of 4. And here we've taken the 4 and times it by the 2 to get x to the 8. Now remember, you don't have a calculator on this exam, so if you're struggling to figure out what 3 to the 4 is, it's helpful sometimes to just write it out step by step. That really means 3 times itself 4 times. So if I'm going to write that out, I might start with 3 times 3, and I usually write the answer below. That becomes 9. So 2 3's becomes 9. Times it by 3 again, we get 27. That's 1, 2, 3 3's. We need to use one more, so times it by 3 again. If you're not sure, you can count it out. You can do it the long way, 27 times 3. Anyways, whatever method you get to, you'll get to 81. So again, that's using up 4 3's, 1, 2, 3, 4 3's, and you get an answer of 81. So this becomes 81 x to the 8th, and you're done. Another example we could look at similar would be a problem such as this: 2y to the 3, x to the 4, in this case to the power of 3. So here again, take the power outside the bracket and put it onto the number, so that's 2 to the power of 3, and we're going to times the power to the number, or times the powers on the letters inside as well as the power to the outside, so that's 3 times 3 becomes 9, and on the x we have 3 and 4, so 3 times 4 becomes 12. And we're not done yet, we need to simplify the 2 to the power of 3. So that's 2 times 2, which is 4, times 2, which is 8. So that uses up 3 2's, we get an answer of 8. So this whole thing simplifies to 8 y to the 9, x to the 12, and if you're being super careful, you probably write it in alphabetical order. So it becomes 8 x to the 12, y to the 9. And if we keep going with these simplification rules, another example that they can give you is one where we're dealing with a fraction here. So in this case, we need to think about dealing with it as a fraction, so we're going to simplify the numbers in front, just as you would if it was a fraction. Sorry, numbers in front. And then we're going to subtract the powers. So if I think about just the numbers in front, meaning the 18 and the 6, if I had just a fraction, 18 over 6, I might think to myself, what can I reduce from here? How can I simplify these? And one way to imagine that is to think of things at times to 18, 2 and 9, 3 and 6. If I look at 3 times 6, can I write 6? Well, I can just keep that as a 6, 6 times 1. And the 6 and the 6 are both in those numbers, so I can actually take them out, and I'm left with just the 3 over 1. And now for this rule here, subtracting the powers, we've got 6y on top, or y to the power of 6, meaning there's 6 y's times together. And we've got 3 y's times together on the bottom, the y to the power of 3. So the simplest way to do that is just to make a subtraction between those two numbers. So this becomes y to the power of 3. But another way to visualize that, if you would like to, is that this is going to be 3, and there are 6 y's on top, and 3 y's on bottom. And we can cancel them off one for one with each other. So if I take 3 off the bottom, I have to take 3 off the top, and I'm left with the 3 y's there. And again, y times y times y is the same thing as 3y to the power of 3. So this is your final answer.